How we all doing?
Pretty good.
So we'll probably have some time to work on, well, I wanted to show just some more animation techniques in 3ds Max, as well as give you time to, troubleshoot anything you might be using to blow up your pumpkin and set up your scene and things like that. Give you some time to work on that while we're in class. So I'll try to be brief here. So what I want to talk about today anyway, and I'll try to be brief, is the physics engine that's in 3ds Max that allows you to use physical properties to do the animation, if you will. So I'll just show you, we'll just set up a simple animation to see how that works. So let's do let's just put a floor down, not that we have to actually, but we'll just have a nice floor. We'll set the length and width segments here. All right, and of course we'll need a sphere, and we'll put it up in the air here. Okay, and what's I think it's in the extended primitives. I wanted to do like a wedge. Maybe it's a prism. Let's see. Yeah, that's sort of what I want, but I'm going to draw it in the front view. I mean, yeah. Draw that out. Something like this. That'll work. Give it some depth. Okay, that's a little freaky. I don't use that one very much. Pretty useful. So I'm going to put it under the ball. And close enough to the floor. Okay, this is probably good enough. So here's my setup. So using the physics engine, I should be able to just drop the ball on there and have it bounce off, and perhaps run into something else. How about something interesting like a teapot? Let's see, where's my teapot? Regular pyramids and teapot. Okay. Nice little teapot. See if we can run it in there. This time I think I will use the scale tool, make it a pitcher. It's the teapot. Okay, and the one thing I would want to do, just because it's going to be animated, is in the hierarchy panel down here at the bottom, we can reset the scale, and so that gives the teapot. If I look at the scale. Transform type in, it thinks now, because I reset it, that the teapot is scaled 100%. So that should alleviate any potential animation problems I might have. Okay, and the other thing I want to do is make sure that it's lined up. Maybe the U's. There we go. We should hit it, I guess, at this point. Okay, so how do I set this up? I could just keyframe animation, this thing, but here's another way to do that. Right click, and I'm going to go to what's called the MassFX toolbar, and that should pop up. Oh yeah, it's off my other screen, so let me put it. Okay. So here it is. Here are the properties. This allows, I'm going to select the sphere first, because this is a different kind of object than perhaps the wedge and the teapot would be. So there are different kinds of objects here. There are rigid bodies and soft bodies. There are 3 kinds of rigid bodies, and we'll try to decide which ones are which in this little simulation here. A dynamic rigid body, you might think is something that moves around, right? But so would a kinematic rigid body. And then a static rigid body would be something that didn't move, right? So in this case, we'll use something that, well, actually, I think all of them could be dynamic right now, because a kinematic one has an initial keyframe animation to it, and a dynamic one is just something that's going to move. So the teapot would also be considered a dynamic rigid body. So I've added both the sphere and the teapot as dynamic rigid bodies. Now the wedge or ramp, let's call it ramp, could be considered, it's not going to really move. It's like nailed to the floor or whatever, or I could have it as a dynamic rigid body and just very heavy, so it could move when the ball hits it. That might be interesting, but I'm going to leave it as a static rigid body for now, and then we'll play with it and see what we can get. Okay, so now I have these three. What about the floor, though? You don't actually have to mess with that, because the 3ds Max world, the floor is at 0. It used to not be that way, where if you drop something, it would fall completely. It would fall forever if you didn't have a floor, or if it rolled off a floor. So in this case, I think that'll work. Okay, now we didn't set up any properties or anything, but we could, right? And so just picking the sphere back, I have a modifier added to the sphere, and we have some properties here, such as density, mass, some friction properties, and its bounciness and things like that. So let's just see, and as do the other two objects that I've put into this scene. So let's see what happens. So we can run the simulation, right? So we can start it without animation or with the animation. So nothing's animated right here. So we're just gonna click start animation and let the ball fall. And that was just beautiful. That was great. So I'll go ahead and run that back. Okay, pretty good. The only problem is, I don't know how big this sphere is or how far away that teapot is, or, it's just not that high off not that tall. It's not falling from that much of a distance. So let's give it a little more distance, maybe. Okay, let's run it again. There we go. Now we're able to hit it because we gave it more energy, right? So didn't have to do any keyframing, just we're able to set the parameters and let it run. So this simulation is all well and good. There's also something that you can do to refine it a little bit, but I'm going to go ahead and open up the properties, the multi-object properties thing, world parameters and whatnot are in here. Oh, yeah, it's over here. Let's pull this in here. So I have some settings I can use, such as the world parameters. Right now the ground height is at 0, but if I needed it somewhere else, I suppose I could put it above the ramp, and if I ran that simulation, it would, it didn't seem to, maybe that wasn't high enough. That's weird. Anyway, reset that.
Hey, Brian.
Yep.
Quick question. If you're doing that with the animation of the simulation and everything like that, and you don't use keyframes,
Yep.
does that mean every time it drops, it'll fall the same place, or would it gradually, like sometimes it'll fall like to the right or to the left?
Yeah, good question. A lot of times, well, gravity is, it does use gravity in the scene, although I didn't add a gravity to it like we were used to with particles and things like that. But the way the engine works, I don't think, well, you could try it. I think it'll be very close each time you run it. Every time we run the simulation, I should see that ball hit at the same place and then end up in the same place. However,
Okay.
Yeah, go ahead.
On mine, it's kind of just randomly, just depending on how either one, because I had one that went to the left, and then so I was just wondering if it does change over time, or like just sometimes it'll go differently. Like I guess in real life, it's not going to fall exactly where, or when the ball won't stop exactly where the last one stopped. It'll just keep changing. So I was wondering if it does that too, if it calculates that, or however it does it.
It does depend on the calculations. So if there, you're going to get some rounding error, and yeah, it'll be slightly different each time. In this case, it's simple enough to where I don't think you could tell. Now, if I put the ball such that it's exactly, let's see, let's put it at the center of the world here, and same with the teapot. Now they're exactly aligned with each other, and let's try running that. I think because it's, yeah, there we go. So yeah, just by moving it left or right, it shouldn't have bounced over the teapot, because I only moved it laterally or whatever, but this time it did. So let's put that ball down a little bit. So yeah, if I'm trying to simulate, nice. Okay, almost. I could just give it more mass, for crying out loud. Let's give it 25. And maybe turn down the bounciness, right? Okay. 0.35. Heavier. Wow, it totally missed it. That's so interesting. I'm dropping it directly from the top view, and it's bouncing to the side, everything being. Oh, and the reason for that actually is, so as far as the answer to your question goes, yeah, you can see some slight differences. Notice also, yeah, so yes, here's your short answer, I guess.
All right.
Notice when I run the simulation, I have this teapot, and it starts moving before the ball hits it, right? So if I run this, see the teapot's wobbling, it's like, oh, I'm on the floor or something, and then it wants to do something. So in the settings here, if I go to, let's see, simulation tools, well, I can actually look at it over here. What I want to do is hold it in position until something happens to it. So yeah, I think I need to start in sleep mode. Maybe that's it. Let's see. So now it's not moving, and then if that ball would hit it, it would do something, right? So let's look at this ball. Zoom in on it. Oh, let me run that. Okay, there we go. So when I added the ball to the simulation by just selecting it as a dynamic body, it did its own meshing of that sphere. Okay, so the number of sides I have on it, if I go here, the number of segments, if I increase or decrease that, it's not going to help at all. It won't do anything to the simulation. What does help with that simulation is the parameters of the object itself. So let's go to my object editor here, and so under the mesh parameters here, I'm treating it as a convex mesh. So it's just a round mesh that it's not concave. And here's where I can set the number of vertices and such. So let's up that to 128. Nice. So now I have a more accurate rendition of that. And so when it collides with something, I'll have more vertices or more edges to actually interact with the edges of the object. So I would expect that the ball will bounce more straight, more true to its character, to its geometry than if I had a low number of vertices. Let's just see what happens here. So yeah, just by increasing the number of vertices that it uses to model the ball, I get a different, it bounced straighter, right? I was able to hit the teapot with it by that. So that's nice. Let's put that up a little bit, give a little more energy. Let's put the bounce down a little bit on this as well. A little bounciness. Let's go 0.15. So more of a concrete ball. At least it knocked it over, huh? There we go. Okay, so those are the ideas behind just regular collisions and things. Okay, we okay with all that so far? Any questions? Let's up the mass quite a bit. Let's go 500. Let's run it. So yeah, it had a much greater effect on that on that teapot just because it had more mass. Okay, what's the mass of my teapot? A bit more, and we can see its meshing is pretty inaccurate, right? I'd have to up the number of vertices for that, but in this case, just because it's running into that, it doesn't matter so much. So, all right, let's do some other simulations here.
So Brian, how you were talking about like the mesh not being accurate on, say, like the teapot, would that only matter if you were doing something like if you were to simulate water pouring over it? And then obviously that would matter from then because it wouldn't be matching or going around the teapot, correct?
Yeah, yeah. So, or if you had bright sand or something, a lot of like particles or whatever, it would be bouncing off nothing, right? So you would see your render of this would be seen as, the sand not hitting the pot and bouncing off of it or whatever without ever touching it. So that the closer you want on that, the more computer resources you're going to use, the more likely you'll crash it, right? So save often when you're doing simulations like this, by the way. And
okay,
yeah, so the higher density or the higher number of vertices you have in the mesh, the more accurate it's going to look. Now, yeah, but with a big ball hitting this pot, you wouldn't need that many. So yes, that was good.
Alrighty.
Okay, I'm going to go bowling here. So let's just put this sphere at one end and we'll try to make a little, and so I'm going to animate this sphere. And this is my bowling alley now. And I can give it an initial velocity, right? So pretty easy to do. That's just with our auto key. So we're going to combine these tools in here. So maybe the first second, I don't know, does that take to swing the ball and give it a forward motion? Maybe from here to up a little bit. So somebody's swinging the ball in kind of a swinging motion, although I don't have that swinging, it's just going to go from here to here. So maybe halfway in between, I put a little lower. So now it has a swing motion. Okay, then I'm going to let go of the ball, right? And let the universe decide what happens. So So, but I do need to change it from a dynamic rigid body to a kinematic rigid body. Okay, and so let's look at its settings. This box is a lot easier to use than maybe the modified panel on the left, but it has very much the same settings and things. So in the settings for this object, it's kinematic. I wonder if I have to undo that. No, I guess I think okay. And so until frame, right? So I want to set when it's, actually, if I don't check that, I can set what frame it starts at. I think so. Let's just see what that does. Just by doing this with nothing else, let's run that simulation here. Start swings, and there we go. Okay. So I think I need to put that at 100 and run it again. Oh, let me stop it. All right, let me, I think it's okay. Actually, I think I might need to do it until frame 29. It's kinematic. Let's see. There we go. Let's uncheck until frame and see what the difference is. Yeah, so it's going to read this animation until frame 29. But if you go until frame 30, I don't think worked, actually. I think you have to do it inside the actual animation of it. So maybe that 30 might have worked. Yeah. So it didn't have enough speed, basically, to go much further here. So actually, until 29 went a little further, didn't it? It did. Okay. So I'll leave it at 29. So if I wanted to go faster, I would just have that swing in a shorter time, right? So I'm going to move this down to half a second. And then put this until frame 14. Let's see what we get. Yeah, there we go. Went a little further. Okay. I want it to be faster than that. So let's put it somewhat half between 8 and 4. That's 7. Let's do 6 and 3. A little bit speedier here. Let's try 5. Okay, one frame made a big difference. Let's give it a little more time here. Okay, what frame do I have there? 8 and 4. Okay. Let's go into frame 7. a little too much. Okay, I think that's close. Let's lengthen up our floor. And then we'll put something over there to hit. I have some more work to do on the density of the ball. I think I need more density as well as I don't know what units these are in. These are just 3ds Max units. Although you could change your units to actual world units, but in this case, we're okay. A little bit less friction. Let's go half of that. The balancing this is pretty good. Let's see how it goes now. All right, a little less static friction too. Okay. Just need some bowling pins on the other side here. Let's use a lathe for this. So probably these grid snap. Yeah. And turn the snap off for a minute. Yeah, it's not a great bowling pin, but we'll go with it. And lathe it. Then. All right. Good enough. Okay, I'm going to add this to a dynamic rigid body. It's not going to move to start with. And I probably need a few more. Although when the ball hits it, that's probably going to be okay, but I'll just increase the settings here. It's mesh. Let's go 64, double it. Yeah, we may need a little bit more. Oh, and it's treating it as a convex mesh. If we treat it as a concave mesh, then it's gonna, well, generate and let it reread it. And so it's a little more complex, quite a bit more complex. And I might need to increase the mesh detail would actually help. Let's regenerate that. Yeah, wow, let's do 100%. Yeah, even at 100%, it's still looking, it still can only do that. Let's try 512 on the max. I don't really want to do that. That didn't help at all. Pre-fitting. A little bit better. Wow. Let's just try that. There we go. Minimum hull size, right? So let's try 1.15. Okay. Yeah, we certainly don't need it that good. So let's go back to 90. Okay, I'm going to leave it like this. As far as the collisions go, that should be okay. As far as mass goes, whoa, did I? What happened? Oh, capsule. I must have rolled my mouse wheel on that, sorry. Okay, back to normal. And I don't know about its mass or its bounciness, but we'll see what happens when the ball hits it. Let's go back to top view. Okay, I want 10 pins, right? So could use an array command. I need the effects extras. And there they are. And on the other screen again. Okay, here's the. So let's preview what's going to happen here. The incremental offset in the X direction. So how many rows does 10 pins have? I think just 4, right? Yeah. 4 rows, and I'll set that offset. Just kind of visually get it. I'm also going to need maybe some Y direction here, so it tilts it, right? Okay, and then in the 2D array, it's still Y. Let's go this way. I set it up this much. I'm gonna crash it. Okay, need another row. So I have 4, 3, 2, 1, right? That's 10. And I can delete the rest of those. The rest of those. Okay. Oh, what happened? What do I need? 3? 4. Yeah, that way I can get to this. Yeah, it's really slowing it down. Gotta be careful. Okay, that's good enough. Okay, so these guys here, so I'm going to use just a lasso tool. Let's go around here, get those guys and delete them. Okay, so that should be a good enough array of pins. They're kind of small, and they're okay. Yeah, maybe the scale is a little different. That is pretty far away. What if I move this a little closer and, well, let's just see what it does. Okay, so I need all these pins to be static, no, dynamic rigid bodies. And I need to set them in sleep mode, collide with rigid bodies, use high velocity collisions. I don't know if I'll need that. And yeah, we can change their bounciness. So this is a multi-object editor. That means I can change all of them at once as far as their parameters go, like the mass and things like that. Let's up their bounciness a little bit just to be fun. 0.8. All right, let's see if we can get the ball to hit it. So close, so close. Okay, maybe can change the animation a little bit, and we take out this middle keyframe. Scoot this down and set that keyframe. It's still going up. Let me lower that down. Oh, put on auto key. Put that down a little bit. So now it's going to be coming down at the ground and until frame 6, maybe 5. Let's see what we get there. Nice. Well, almost nice. Did the ball go through those pins or did it just miss them? Let's look at my top view here. Could have gone over them for all I know. Let's look at this view. Turn that off. Okay, I'm guessing that's a little too fast. um, one more keyframe out and let's see what we get. Almost a little better. Let's go to frame 6. Still pretty unsteady. Okay, until frame there. Oh, I see. For some reason, let's just bring that back to normal here. Oh, we're not in auto key mode. No wonder. Okay, now bring it back. Oh, these are big numbers here, so I'm gonna put it right in line with that. Make that Z coordinate just a little bit higher. All right, let's see if that's normal. So frame 8, so up till frame 7. Okay. Okay, that looked pretty good. I think we have a mass problem. Let's see if that ball gets there. I think it missed that first pin. All right. We could reduce the mass of the pins by a bit. make them bounce around a little bit more. Let's see, and the ball. We'll increase the mass some more, 5,000. We use 10,000. All right. Hopefully it'll do a number on the pins. Let's just look at some of okay, so I'm using a preset on this, and let's see what that gives us. So mass 89. Let's look at the ball. And change this preset to steel. It's not going very fast when it's hitting, so we'll just see what we get. Well, it missed. With that preset. Get a little more velocity, I guess. Let's go with 5. That's pretty good. Just gonna have to give it a little more speed. So I'll just push it a little bit further. So speed can be changed by decreasing the time or increasing the distance, right? So well, let's see what we get. Those are some tough pins. Now, that is, I'm starting them in sleep mode. If I don't, seems like they're still in sleep mode. Yeah, they knock over a lot easier, but they're not standing up. Stop. And then I think they're in the floor, so let me pick them up a little bit where they're off the floor. And then start them in sleep mode. Dang, I rolled my mouse over that stupid. Gotta choose concave again. Actually, let's go with, oh, that's great. Let's go with something simpler and I might get a better, so let's just try convex. And so it'll still bounce around okay. And I might get a better reaction here. There we go. So being concave, it really kept it from reacting well to that ball. So that was my whole problem. Leaving it at convex helped a lot. Let's, good. What else could we do? Let's actually use an instance where concavity is a bigger deal, like putting something inside of something else, like a bowl or something. So let's take this back. Let's delete the animation on this. Change it to a regular dynamic rigid body. Actually, I'm going to take it out and I'm going to increase the radius. No, actually, I'm okay with that. So let's just add it as a dynamic. All right, let's build something such as, we could use, lathe and stuff, but let's just do another sphere. So we put it right under this one, just bigger. And let's put the hemisphere at 0.5. That'll work. And yeah, flip it over. $180. Need to put it above the floor. There we go. Select the sphere, put it above it. Okay, I need to hollow that out. There's a couple ways to do that. An easy way would be to just convert that to an editable poly. And then go to polygon mode. Turn the window on. So I'm just going to select the polygons inside there and delete them. And now it has no thickness to it at all, but we could add a shell modifier, get it out of subobject mode. Shell. And outer amount. Give it some thickness. Doesn't need to be much. Okay, so this is going to be a static rigid body, and the ball's going to fall inside of it. So static rigid, it's not going to move, and it's going to be a little. This is definitely going to have to be concave. Concave. Concave objects are way better if you put them on static. And then, yeah, I think I probably want a minimum hole size of a bit smaller just to be better with that. So 0.15 maybe. Generate. Yeah, I'm still getting some lines across there. That's going to be tough. So let's try 100. Yeah. Generate again. Still getting lines across there. This one's going to be tougher. I have to jump that up. There we go. Okay. Looks better. All right, now the sphere, let's put it over on the edge a little something like that. So when it falls, it'll catch the edge of the sphere and do something. And we can adjust the bounciness and stuff, but let's just see what we get. That was great. Maybe a little higher. Nice. I like it. Let's make some copies. Shift, drag it upwards a little bit. And make 15 copies. They're all instances. Okay. All right, let's see what that does. That was fun. Let's see if we can crash the computer here. Let's go a little bit to the left. With maybe 3 copies of those. Nice. Oh, machine's doing pretty well, actually. I'm impressed. Okay. Any questions? I could go all day with this, but that's some basic simulations. There's some more in here that we can talk about, but the next one is probably, yeah, I've gone way longer than I knew. Well, I kind of knew this would happen. I do want to talk about cloth bodies, which is nice. So let's say, let's delete these spheres. That'll be easiest to replicate later. Okay, so simplify it up a little bit. Let's draw a rectangle or even a circle. Let's build that over the center of this. Maybe quite a bit bigger, twice as big maybe. Okay, and I'm going to add a special modifier to it. Well, they're all special, I guess, but the garment maker will, you'll see what it does is it meshes this. And what this does is it allows it to fold and bend more naturally. So let's see what we get with this. We can increase the density of this, but be careful because it could really increase your, so I'm going to do this in small increments. So there's 0.074, and so that's much more dense, but still reasonable. Okay, and so I'm going to add this to a cloth object, or you could remove it. So anyway, there we go. Now it has a cloth body to it. And gee, I think that's all I need to do. So I'm going to put that over my static rigid body and just run the simulation. It's going to fall because gravity takes over it, and because it's a cloth body, it's not a rigid body, it can fold, right? So and then, you know, it looks kind of stiff, but we can certainly change the settings here. So not in the MassFX tools, but in the actual mCloth modifier, we can do some settings here, such as bendiness. Right now it's at 0. Stretchiness is also at 0, so we could give it a little stretch. This is, and give it a whole lot more bendiness to it. So a little, I think it just goes up to 1. Yeah, so I'll put it at 0.8 or something, or 0.7. Okay, just those two. A little bit of stretchy, a little bit more bendy, a lot more bendy. So there's it. So it's, you can tell it's stretched more, so much more natural looking with that. So okay, so let's do one more thing here. Do all kinds of stuff. Put a sphere on top of it. Move it up here. Oh yeah, well, we don't want that, so 0 that out. Okay, and we're gonna add that to a dynamic rigid body. Okay, that's it. And run it. Okay, now here, I just click the start button again, and then let's say I wanted to, well, let's go back. Let's just try something else. I'm gonna stop the animation right here. So I like this model, right? I mean, how would you like to have to model that up, right? So in this case, I think there's, where is it? Convert to custom shape. Let's see, create new editable mesh and set this mesh type to custom. I think that's all I wanted to do. So at this point, this, oh wait, I just committed. Okay, let me undo that. I have the wrong thing selected. Let's run this animation again and stop it. Yeah, let me delete that guy. So what I did is I just created a mesh out of that sphere, but what I really wanted to do is do the same thing with that clock, because that was pretty pretty nice modeling here, right? Just letting. So let's see, where am I? You can actually allow tearing. You can, so as we, well, we'll see. It's in here somewhere. Capture target state. Yeah, that's kind of showing it where it should be. You can also live drag it. So in this, we can actually pull some of these parts away from it. Yeah, somewhere in here you can just capture initial state, the current pose. Yeah, that's it. So let me, before the ball hits it, I want to hold this like that and capture the state of it. And then if I reset it, it should, so now I have that cloth as around so now it looks just like a table with a tablecloth or something. And then when I run the simulation, it doesn't have to do anything, just kind of sit there. Maybe it's a little too stretchy still. And then the ball comes in and does some stuff. So nice. Okay, one more thing. And then I promise I'll shut up. So let's use the front view here. Yeah, let's go ahead and delete these guys. Don't need the sphere anymore. let's just hang some curtains on on a wall or something, right? So that's the idea. So I'm just going to make a rectangle for this one. And so here's the curtain, let's say, just one panel. Okay, I'll add the garment maker modifier to it. Nice density, I like it. And I'm going to add this to the mcloth object. Okay, in the mcloth, I can actually set some vertices. So I'm going to select like the top couple rows. In fact, I think I can make it a soft selection. Yeah, use soft selection here and increase the fall off. So yeah, it's going to be a range of selection here. And further down, I want to make a group out of this selection. So group one, big deal. Okay, so group one is unassigned to anything. And the most common thing to do is pin, holds the vertices highlighted still. So there I go. Now I've pinned those together. And now, well, I got to do something to it, I guess. So there I go. I have this cloth modifier on this object. So perhaps I need something to run into it. Oh, we can add a wind. How about that? So in the create, we can still use forces such as wind. That's the way I wanted to go with it, sure. Okay. I don't think it matters if I'm in front or behind the object, but just for grins, we'll put the wind behind it. So we can. All right, let's just see what that does. Oh, I need to, okay. I think this wind does need to be bound. So the space warp, find a space warp, and let's see. Yeah. So this object in the modify panel, it has the wind bound to the cloth. And so I think that that would do what it's supposed to. Wow, not much. Just needs to be dynamic. Might need to be closer. Let's rotate it. Oh, I made all the other vertices pinned to it, so let's delete this. Okay, I do need that constraint on. So it's just super stiff. Okay. Um, shouldn't need any of this. Okay, that's on vertex. Let's go back to cloth. Stretchiness. Let's do some more bending. Oh yeah, that had bendiness at 0. So 0.7. Um, yeah, let's just see. Hardly at all. Is that wind just not? Back down. Strength. Add some turbulence. I think the cloth still needs some work here. I don't think that's gonna help too much. Bendiness should have really helped. A little bit of stretchiness. Lower the damping. Lower the friction. Yeah. Okay. That looks like the wind is not bound to it for some reason, or the let's take that wind. I think we're okay with all this. Okay. So well, let's see. This should have worked. I have to look into that, why this wind object is not doing what we think. Yeah, it has no effect at all on the cloth. It really should. There's no decay, so it's not, doesn't matter how close it is. Unless you put a decay on it. Yeah, it's out of range for some reason. I'm not sure why. Still doesn't help. Anyway, I'll look that up. But we can, throw balls on it and have that react to other forces and things. I'm just not sure why this wind is not affecting it like it should. Have to look at it. Okay. What else? I think that was about it, using cloth and rigid bodies to simulate different animations, and that'll be our next assignment. Is just to set up a nice scene with some good materials and sound, and use the MassFX physics engine to run some. You can increase, or you can implement regular animation in it as well. And once something is animated, it can be. I'm going to go ahead and detach those. So now when I run it, it should just fall. Okay, there you go. So let's say that's my animation. Yeah, well, that just didn't work. Let's take the wind out of there for a minute. Okay. So once we have an animation set up the way you like it, I kind of don't like that. Let's put that over the. It's just you interact it with the sphere or something. So okay. Here we go. And what I'm going to do is start simulation. And actually, I don't need to start it. Well, I'll play it one more time. So it falls over that. It's not as good as the other one was, but that's okay. And then I'm going to bake. Okay, baking basically creates keyframes for the animation, the simulation. So this is how you can get back to your keyframe animation. So we're just going to bake so it's building keyframes for the object in question. Okay, when it's done, there we go. So now I can just run through the animation and do other things with it, such as, I think I'm done with the live drag though. In that cloth, it's already, I have to unbake it, basically remove the animation from it if I want to, drag it around and do something else with it. And so now I have this object and it's totally animated and in the scene animated, just like if you did it by keyframe. So that allows, you can do that with any of the objects, so, or bowling pins and whatever. So, all right, that's it for today. Be thinking about what you want to do, and we'll look into these forces a little bit more, like adding wind and pushes and vortexes and things like that into our animations, and even particles and stuff. So that's a nice combination of using particles and the MassFX. So we'll do that next time too. All right, so that was long-winded, but we okay? Everybody all right?